All right, so today our topic is actually a very convenient, very easy topic, and this is reversible reaction, reversible reactions. The idea of a reversible reaction, as the name suggests, is that this reaction can produce reactant from product and product from reactant. Because normally, how does a reaction occur? You have reactants and you have products, and usually reactants become products. An example, you have glucose in your bloodstream, reacts with oxygen, and creates carbon dioxide, water, and releases some energy that fuels our bodies. Sometimes products can come back to reactants. For example, the same carbon dioxide and water is used in plants to make glucose and oxygen gas. Now, is this a reversible reaction? No, because it's not happening at the same time. Our bodies can produce carbon dioxide and water, and plants can produce oxygen and glucose, but not all of that is happening at the same time. It's not that the same carbon dioxide that we exhale is being converted back into glucose inside our body. It's not. It's in a completely different place in a plant. But if the same thing were to happen in the same stage, in the same situation, then that will be a reversible reaction. If reactants can change to products and same products can go back to reactants in the same reaction area, in the same reaction vessel, that's a reversible reaction. Or we can say that this is a reaction that can go in both directions. It can go in the forward direction and can go in the backward direction. So that's a term you will use multiple times. We'll say this is forward direction and this is backward direction. Okay, so we'll use it multiple times to explain what's happening. So I'll give an example. A very famous reaction of this type is nitrogen reacting with hydrogen, producing ammonia. Let's balance this. Okay, so that's what we have. Now, what this means is that if you have one reaction vessel in which you have nitrogen reacting with hydrogen, making ammonia, then same ammonia can go back and produce nitrogen and hydrogen in the same vessel, in the same situation. So this can go back, which is backward reaction, and this can go forward and make that. Okay, so that is what we have. It has to happen in the same vessel, and it can go in forward and backward direction. That's what makes it a reversible reaction. So what happens? Initially, all you have is just nitrogen and hydrogen. कुछ और होता ही नहीं है आपके पास. सिर्फ नाइट्रोजन है, हाइड्रोजन है, कोई अमोनिया नहीं है शुरू में. तो अब there is no ammonia to go back. So all that's going to happen is nitrogen is going to react with hydrogen, start producing ammonia. So we say that at the start, reaction is going forward more and backward less because there's very little ammonia. After a while, ammonia is made up. So now this ammonia, as it's made up, starts going back again. So the rate of forward reaction and rate of backward reaction are different. But after a while, as more and more of ammonia goes back, the rate of forward reaction and the rate of backward reaction becomes equal. Now, initially, if this is reacting faster, then you will see that ammonia starts to increase. So if I were to graph it, then this is time and this is volume of whatever thing in dm cube, for example. Then initially you will see that ammonia, let's say this is where ammonia is, this is where nitrogen is, this is where hydrogen is. So initially there's no ammonia, but after a while it starts to get made up. And as ammonia gets made up, nitrogen gets used up and hydrogen gets used up. But after a while, you will see that ammonia stops to become more. It becomes constant, a fixed value. And same for hydrogen. It starts to decrease, but it reaches a fixed value. And same for nitrogen. It starts to decrease, but reaches a fixed value. And you will notice that they all reach a fixed value roughly at the same time. This situation where they're all reaching the constant value, this time is called time of equilibrium. Why? because this is where equilibrium has been established, and we'll call it dynamic equilibrium.